So we discussed the organic chemistry. Now we'll start the topic. The introduction is finished. First thing, a crude oil or petroleum. A crude oil or petroleum, it is a mixture of hydrocarbons. Means different hydrocarbon, the compound which contain carbon and hydrogen only. So when we have a mixture of hydrocarbon, these hydrocarbon mixed together, what we call that as a crude oil. And this crude oil consists of bitumen. These are the hydrocarbons present in a crude oil, fuel oil, diesel, paraffin, or kerosene, petrol, or gasoline, naphtha, and gases, different gases of hydrocarbon. So basically, what is a crude oil? Crude oil or a petroleum, it is a mixture of hydrocarbon. And what are the substances present in a crude oil? It consists of gases, gasoline, naphtha, kerosene, diesel, fuel oil, and bitumen. And these hydrocarbon, they all, like all these compounds which I list here, they are all hydrocarbons, means they contain carbon and hydrogen only. But what is the difference between them? The difference is the number of the carbon present. So the number of the carbon and hydrogen present in each compound, like bitumen is one compound having different number of the carbon atoms. Fuel oil is another compound which is having a different number of carbon atoms. Diesel is another compound having different number of carbon atoms. Paraffin or kerosene, different number of carbon atoms. Petrol, naphtha is there having different number of the carbon atoms. Petrol or gasoline having different number of the carbon atom. And the refinery gases, we also call them refinery gases, they have different number of carbon atoms. So basically what happened, moving from bitumen to fuel oil, then to diesel, paraffin, kerosene, what we observed, number of the carbon and hydrogen will decrease. So number of the carbon and the hydrogen which are present in the molecule will decrease. And what is the effect of number of the carbon and hydrogen present in the molecule? The boiling point of hydrocarbon is proportional to number of the carbon or number of atoms present in the molecule. So the number of the atoms which are present in the molecule will affect the boiling point. Which one you think will have the higher boiling point? Bitumen, fuel oil, diesel, paraffin, naphtha, petrol, or gasoline, or refinery gases? So bitumen, because as we know, the boiling point, as there are more carbons, there is greater attraction between the molecules. That is why bitumen will have the highest boiling point. In short, I'm writing BP at a boiling point, and refinery, because these are gases at room temperature, so they will have the lowest boiling point. Then what is the another effect of number of the carbon? Like as the number of the carbon increases, or it is in terms of burning as well. So as the number of the carbon and hydrogen is decreasing from bitumen to gases, the boiling point is decreasing. Then burning, combustion, depends on number of carbon present in molecule. If smaller number of the carbon, the compound can burn easily. So the combustion depends on the number of the carbon atom present in a molecule. If we have a small number of carbon, the compound can burn easily, like a complete combustion. If there are greater number of carbon atoms, then likely incomplete combustion. So which substance you think can burn easily? So the refinery gases, or gases can burn easily because they have few carbon atoms. So I will represent by an arrow. So moving from this arrow, what it shows moving from bitumen to refinery gases, it become easy to burn. The amount of energy released by the hydrocarbon depend on the number of the carbon atoms. So which one you think if we burn completely, like because refinery gases are easy to burn compared to paraffin or kerosene and or a fuel oil. Which one you think will release more energy moving from bitumen to refinery gases when we burn them? Energy released by hydrocarbon depends on number of the carbon within the structure. So more carbon atoms, greater inner amount of energy is released. So bitumen will release more energy. So moving from bitumen to gases, the energy released during a burning decreases. So refinery gases are easy to burn, but they release less energy. Bitumen, fuel oil, diesel are easy to burn, but are difficult to burn. They release more energy. But when we burn them, if we are able to burn them completely, that will release greater amount of energy. And the boiling point and volatility means the property to vaporize easily. That's called volatility. So boiling point and volatility are inversely proportional to each other. So boiling point and volatility, if a substance is having a higher boiling point, it cannot be easily vaporized. The term volatility means tendency to convert into vapors. So which one you think can easily convert into vapors? Moving from bitumen to gases. So the refinery gases can easily be vaporized. They're already in the gas, so petrol, gasoline. So moving from bitumen to gases, the volatility increases because the boiling point decreases, so it is easy to make it volatile. Now, we want to, because crude oil is a mixture of these all hydrocarbons and they have different boiling points. So which technique can be used to separate these hydrocarbons which are having a different boiling point? So we can use a fractional distillation because fractional distillation is a technique which is based on the separating substance on the basis of their boiling point. So we can use fractional distillation to separate fractions from crude oil or petroleum. So we can use fraction distillation to separate these fractions from the crude oil or petroleum. And you should learn this fractionating column as well. So you have to practice this fractionating column. So this is a fractionating column. You have to learn the uses and the positions of these fraction in a fractionating column. So this is a fractionating column which we use to separate the fractions from the crude oil. So first, what enters the fractionating column as heated crude oil. The fractions which are present in the crude oil, we have these fraction bitumen, we have bitumen, fuel oil, diesel, paraffin or kerosene, naphtha, petrol or gasoline, and refinery gases. So we add a superheated crude oil around 350 degrees centigrade or more than that, about 300 to 50 or 400 degrees centigrade. So what happened even at this temperature, the bitumen, because if the temperature of the mixture is above the boiling point of a substance, the substance will be vapor. If a temperature of the mixture is lower than the boiling point, then it will be a liquid state. So here what happened, when we add a crude oil, all the fractions except bitumen are in a vapor form. So the bitumen, which is still in a liquid state of thick viscous liquid, so that will flow out from the bottom. So at this point, we have bitumen at the bottom of the furnace. But what happened to the remaining fraction? For example, we have fuel oil, we have diesel, we have paraffin or kerosene, naphtha is there, and then petrol or gasoline, and at the last gases are there. At this part, what we have these are known as the bubble caps. Now what happened, because a crude oil, which is a mixture of bitumen, fuel oil, kerosene or paraffin, diesel is there, then naphtha, petrol or gasoline, and refinery gases. So these are the fractions which are present in a crude oil. A superheated crude oil around 350 to 400 degrees centigrade enter the fractionating column. As it enters the fractionating column, the bitumen, which is still in a liquid state, will go out from the bottom. The remaining fraction will rise. As these remaining fractions are rising, the fractions will cool down. So as these fractions from the crude oil rise and they lose energy, so they will cool down. So as these fractions will cool down, so what we have, because as you see the boiling points, bitumen is there, then fuel oil, kerosene, as we move down in this series, the boiling point is decreasing. So which will be the next fraction to condense, to convert from a gaseous state to a liquid state. Bitumen is already in a liquid state, so it is separated. That's done. Now, which will be the next fraction which will cool down? So the next fraction which will cool down will be fuel oil. So as it will rise, and different portion of this fractionating column, different temperatures are there. So as these fractions are rising, they cool down. So the fuel oil will cool down here, and the remaining fractions which still have enough energy, so we are having low boiling point, so the remaining fraction will rise. Then after fuel oil, which fraction will condense? So here we have a fuel oil. Then after fuel oil, diesel is there. So diesel will condense here, remaining fraction will rise. Then after diesel, it will be kerosene or paraffin. Then after kerosene, it will be naphtha. After naphtha, it will be petrol or gasoline. And the remaining gases, because they escape from the furnace in the state of gas, they are not able to convert because the temperature is still higher than their boiling point, so they remain in a gaseous state. These normally gases consist of propane and butane. So this is how we separate the fractions from the crude oil. Then what you have to learn? You have to learn the uses of each. So bitumen is used for road carpeting. Then fuel oil, where we use fuel oil, it is used for ships and power stations, fuel for ships and power station. There are more fractions, but we are only specify, like, not listing all of them. There is also a machine oil. Diesel is there. It is used for buses and trucks. The fuel for kerosene or paraffin is used as a jet fuel for aircraft. Naphtha is a raw material for different products made up of plastic. So it is used in petrochemical. Petrochemical here means chemicals which are made or formed from petrol, from basically petroleum. We call them as petrochemical. So it's a basic raw material for the petrochemical. Petrol is used for cars, and refinery gases are used as a domestic fuel. Like at home, we are using these gas cylinders. So these gas cylinders are actually a mixture of propane and butane. Is it clear? So you have to learn the uses of each fraction as well as the position of these fractions. You don't have to learn the specific boiling point of these fractions, only the position and the uses of these fractions. Why we use, look, the thing is, in the beginning, I mentioned that as there are more carbon atoms, the energy produced will be higher. To move a truck or a bus, we need more energy. That is why buses or trucks are using diesel instead of petrol. Petrol can burn easily, but what happened with petrol, that it does not produce enough energy or sufficient amount of energy to move the truck, or even it can move the truck or the bus, but not to a high speed. Like even for 80 km/h, it will be difficult with petrol to move the bus or truck. That's why we are using a diesel. But you will commonly find when the buses on the highway, you will find the exhaust fume, the vapors, the exhaust gases which are coming out from the bus are mainly black in color, like having a black smoke. Reason for that, because the diesel, I told, as the number of the carbon increase, it will become difficult to burn the hydrocarbon. So chance is there that incomplete combustion may occur, and if it incomplete combustion, in that case it will produce a black smoke. But for cars, you don't find that the black smoke is coming out. Reason is, until unless the engine is not powerful for the car or it's too old, otherwise you will find that it does not produce a black smoke. Is it clear? So this is a fractional distillation of the crude oil. When we compare the molecules moving from domestic gas to this uh, bitumen, what happened to the size of molecule? What happened to the size of molecule as we move from refinery gas to bitumen? Increase the size of molecule means number of the carbon atom. It increase or decrease? So size of the molecule will increase as we go down. What happened to the boiling point? The boiling point will also increase. What happened to volatility? Why we do not add bitumen to the car? Because it is difficult to burn the bitumen. Even you will find this bitumen for road carpeting, when they are burning, it produces a lot of black smoke. So it will contribute to a lot of pollution if you are using a bitumen or try to use bitumen in the car. So petrol is sufficient to produce energy. So volatility decreases. And as the number of the carbon increase, it will become viscous or thick and color will get darker. On the next page, I will mention this. As we go down, it means moving down from bitumen to viscosity means property of a fluid to resist the flow. Like example, if you have a jar which is filled with honey and you have a container or a jar which is filled with water, and you transfer both of them into another container, which one, like water or honey, will transfer quickly? The water will transfer quickly, so we say water is less viscous. Honey will take more time to transfer from one jar to another, so we say it is viscous, like thick, does not flow easily. So as we go down the group, here it is other way around, like more bitumen. This is in terms of fractionating column. So which one you think is more viscous? So bitumen will be more viscous. So as we go down in this, the viscosity increases. The color, it gets darker as the number of the carbon increases. The purpose of the barrier for each, where we did not place a barrier, this is just to collect them, because when the vapor will condense, so when they condense, they will convert into liquid state and we can remove them out. Is it clear, the fraction distillation of the crude oil? Then the fraction which we obtain, we have bitumen, fuel oil, diesel, kerosene, naphtha, petrol, and refinery gases. Which fractions you think have a greater or multiple uses? Like which are the more useful fractions here? Bitumen or petrol, naphtha? Which fraction is having a greater number of uses, variety of uses? So the lower fractions, the fraction with less number of the carbon, the fractions with lower carbon number are more useful than the fractions of higher carbon number. So to do or to obtain, so the fractions with lower carbon number are useful or having more uses than compared to higher carbon number. So what we do, we want a smaller carbon number. So what we do, the method or a technique, we use a cracking. What is the meaning of a cracking of hydrocarbon? It means breaking down small, breaking down large molecule into small and useful hydrocarbon or molecule. For this cracking, we use a temperature. We are just only heating and using a catalyst. Not burning, just supplying heat energy. High temperature and a catalyst is used. The purpose of the catalyst is to speed up the reaction or increase the rate of reaction. So normally, like example, if we have a large molecule and these all hydrocarbons are alkane. So what are the products? We have a large alkane. When we supply heat energy, there are two possibilities. It might produce a small alkane and alkene. This is one possibility. The second possibility, it might produce alkene and hydrogen. So these are the two possibilities when we crack a hydrocarbon. From the name, you can understand the term cracking means like breaking. So when you crack something, it means you're breaking. So breaking of the hydrocarbon into small and useful one, this process is known as cracking. And what it can produce, if you have a large alkane, it can produce small alkane and alkene. This is one possibility. Or it might produce alkene and hydrogen. Example, but how you will identify whether a molecule is alkane or alkene? If a molecule is alkane, then the general formula of alkane is CnH2n plus 2. What is the meaning? It means that the number of the hydrogen are always twice plus 2. Like example, if I write a formula C3 and H8, how to identify whether it is alkane or alkene? If it is alkane, the number of the hydrogen will be twice the number of the carbon plus 2. So how many carbon atoms are there? 3. How many hydrogen atoms? 8. So you can see if number of the carbon are 3, if 3 multiplied by 2, so 3 multiplied by 2, that makes 6. And 6 plus 2, that will make 8. So number of the hydrogen are always the twice as compared to number of carbon plus 2. Same thing if I write C4 and H10. What is this? This is also alkane. How you will identify alkane? Because the journal formula of alkane is CnH2n plus 2. The number of the hydrogen are always twice plus 2. 4 multiplied by 2 is 8 and 8 plus 2 make 10. So you can identify from the formula that this compound is alkane. And if it was alkene, the journal formula of alkene is CnH2n. It means that number of the hydrogen is always twice as compared to number of the carbon. If I write C3, what is twice or multiply 3 multiplied by 2? So C3H6. If I write C4, then it will be H8. Same way, if it is C5 and H10 will be there. So using this formula, you can identify whether a compound is alkane or alkene. Alkanes, the number of the hydrogen will be twice plus 2. But in alkenes, the number of the hydrogen will be twice as compared to number of the carbon atoms. So less than a minute left. So I will continue this explanation of a cracking in the second session.